Welcome back to Daily Dose of Space. When we look up at the night sky, it feels infinite. Stars appear scattered without order. Galaxies blend into faint smudges of light, and distance becomes almost meaningless. Everything feels far, but also strangely close, as if it all belongs to the same quiet backdrop. But astronomy doesn't work with feelings. It works with limits. And one of the most important limits we have ever discovered is how far we can actually see. Today, we're talking about the most distant thing humanity has ever observed. Not just far in space, but far in time. So far that the light reaching us began its journey when the universe itself was still young. And understanding this object forces us to confront something unsettling. Because beyond it, the universe does not disappear. We simply lose the ability to observe it. Distance in the universe is not what it seems. In everyday life, distance is simple. If something is farther away, it takes longer to reach. You move through space, and eventually you arrive. In the universe, distance behaves very differently. Light has a speed limit. No matter how powerful the source, its light travels at a fixed pace. That means looking far away is the same as looking back in time. When we observe the sun, we see it as it was 8 minutes ago. When we observe the nearest stars, we see them years in the past. When we observe distant galaxies, we are looking billions of years backward. This turns telescopes into time machines. Not metaphorically, literally. Every improvement in telescope technology allows us to see older and older versions of the universe. But this also introduces a hard boundary. There is a point so distant that light from beyond it has not had enough time to reach Earth since the beginning of the universe. And that boundary defines everything we can ever observe. The record holders of distance. For decades, astronomers competed quietly to push this boundary. Each new telescope brought new record holders, galaxies farther away than any previously known, quasars shining across enormous stretches of space, faint smudges that represented entire systems of stars from the early universe. The most distant objects we see today are not stars like our sun. They are massive galaxies and quasars, powered by supermassive black holes, burning intensely during the universe's earliest eras. These objects are bright enough to be seen across unimaginable distances. Some of them formed just a few 100 million years after the Big Bang, which is already strange, because according to older models, there shouldn't have been enough time for such large structures to form so quickly. And yet, they are there. Every time we push the distance record, we don't just see farther. We discover that the early universe was far more active, complex, and efficient than we expected. The farthest light of all. But the most distant thing we have ever seen is not a galaxy. It is not a star. It does not even come from a place in the universe. It comes from everywhere. This is the cosmic microwave background. It is the oldest light in existence, released roughly 380,000 years after the Big Bang. Before that moment, the universe was too hot and dense for light to travel freely. Photons were constantly scattered, trapped in a glowing fog. When the universe cooled enough for atoms to form, light was suddenly released in all directions. That light is still traveling today. After nearly 14 billion years of expansion, it has been stretched into microwave wavelengths, invisible to human eyes, but detectable with sensitive instruments. When we observe it, we are seeing the universe at its earliest observable moment, not a single object, but the surface of a cosmic horizon. This radiation surrounds us completely. No matter where we look, we see it, and it marks the ultimate limit of observation. Beyond it, there is no light for us to detect. what lies beyond what we can see. Here is where intuition begins to fail. The cosmic microwave background is not the edge of the universe. It is the edge of what we can observe. Space does not end there. Matter does not stop. Physics does not break. The universe almost certainly continues far beyond this boundary, but because space itself is expanding, regions beyond a certain distance are moving away from us faster than light can cross the expanding space between us. This creates a cosmic horizon, not a wall, but a limit imposed by time, expansion, and the laws of physics. There may be galaxies beyond it that will never be observed, events that will never leave any trace in our instruments, entire regions of reality permanently disconnected from us, and there is nothing we can do about it. No future technology can overcome this limit. Why this matters? You might wonder why the most distant thing we've ever seen matters at all. Because it tells us something profound about our place in the universe. Everything we know, everything we have measured, and everything we will ever observe exists inside a finite bubble of visibility. A tiny fraction of whatever the universe truly is. This means our theories are built on partial information, accurate within our horizon, possibly incomplete beyond it. The universe may be far larger, more varied and more complex than anything we can confirm, and the most distant thing we have ever seen is not a destination. It is a reminder of our limits. You might wonder why the most distant thing we've ever seen matters at all. Because it tells us something profound about our place in the universe. Everything we know, everything we have measured, and everything we will ever observe exists inside a finite bubble of visibility. A tiny fraction of whatever the universe truly is. This means our theories are built on partial information, accurate within our horizon, possibly incomplete beyond it. The universe may be far larger, more varied, and more complex than anything we can confirm, and the most distant thing we have ever seen is not a destination. It is a reminder of our limits.